Scientific notation. So scientific notation is when you rewrite a really small or really big number into a simpler form, and that simpler form is scientific notation. It can be noted by a number in between 1 and 10 times 10 to some exponent, and the exponent can be a negative or a positive. So what does that mean? Well, let's say you have a small number such as 0.00109,712. Well, that's a pretty small number. It's not easy to say. We got a lot of digits, so let's convert it to scientific notation. So first thing we see is we need it to make it into a number between 1 and 10. To do that, you're going to have to move the decimal point. So you're going to have to move it over 1, 2, 3. And you're going to move it over 3 and not 4, because if you move it 4, you're going to get 10.9. Here you're getting 1.09. 1.09 is in between 1 and 10, so you're going to get 1.09712 times 10, and here is the tricky part, the exponent. 1, 2, 3. We know we have a 3, but is it a positive or a negative 3? This kind of confuses some people because they think, well, I'm going to the right, it should be a positive, but in reality, it's a negative 3. So it's a negative if you're dealing with a small number. And the way I like to think about this is thinking in reverse. So I take this number and I see negative 3. Well, negative, I go back. So if that helps, think in a negative way to get that number. So let's try a different one. Let's go in the other direction. So let's start with something like this. So 10 to the negative 3. So once again, okay, we got a number between 1 and 10. We got a negative, so we're gonna put some 1, 2, 3, put some decimals in the front, and copy the rest of the problem down. So that's a little easier way to get to know how to do it. So let's do another problem. Let's do a bigger number. So 78.424. Well, we need 78 is bigger than 10, so let's move the decimal back 1. So you're going to get 7.8424 times 10 to the 1. And it's a 1 because we're dealing with a bigger number. As you can see, the decimal traveling that way is a negative, the decimal traveling this way is a positive. So let's do one more problem. Let's do 227.981000. Let's do another one after this, actually. So what do we do here? We want to make this number in between 1 and 10. So 1, 2, 2.2, 2.2, 7, 9, 8, 1. Well, what about these zeros on the end? Are they significant? No. We're making this number as little as possible, so we're not even going to worry about those zeros. Like, we don't worry about the zeros in the front here when we convert. We're not worrying about the zeros in the back. So this is going to be times 10. This is a large number, so it's going to be a positive 2. Alright, let's try this one. Let's try 994862.009813. Alright, that's a pretty big number. We see we got zeros in the middle, and since this is a big number, our decimal is going to go back 1, 2, 3, 4, 5. It's going to be a positive 5, so we're going to end up with 9.9486.2, and we keep these zeros because they're in the middle. If you got rid of these zeros, it's going to be a totally different number. So you want to keep the zeros in the middle. 13 times 10 to the 5th. So that's basically scientific notation right there. So you're getting rid of the zeros in the front, you're getting rid of the zeros in the back, you're keeping the zeros in the middle. If you have a small number, it's going to be a negative. A large number is going to be a positive. And just keep that number in between 1 and 10 and you'll be okay.